Just a moment, folks. We'll get started shortly. All right. So we are going to start now. 1, 2, and 3. Hello. How are you? Good to see you all. Good morning, good afternoon, good evening, wherever you are in the world. Cheers. Nothing like fresh coffee or whatever beverage you enjoy wherever you are. Thank you for joining this Snyk Live, in particular, the Stranger Danger. Yeah, what's up, -1 Vortex? Good to see you in the chat. Stranger Danger, your JavaScript attack surface just got bigger. I'm Brian Clark. I go by Clarky on the internet, and I'm a senior developer advocate here at Snyk. And I'm going to be your host today, taking you through the session. It's a little bit of a presentation, but it's very casual. So if you have questions, comments, thoughts as we go through things today, I'm going to try and switch it up because last time I did this, I followed one kind of path. This time I'm going to fly by the seat of my pants or whatever that expression is, where I'm just going to kind of try some new things today, aka Big Rock Clarky. What's up, Gerald in chat? Oh man, I won an award. Gerald's pointing out that I won the Big Rock Award. So that's me. I got tons of nicknames. Wherever I go, wherever I work, people like to give me nicknames for some reason. And that's what happens. So welcome in. Happy to have you here. Let's get warmed up. Let's get fired up. Excited about the JavaScript issues. So many of them. Yes, there are. So I think what we're going to do today is typically the format it follows. I'm going to do a little bit of presentation. We're going to talk and discuss the topic a bit more, and get you your mind kind of focusing on security, getting into the right mindset for that, and start a discussion essentially. Okay. Then from there, we're going to get into demos, and we're really just going to fill out the rest of it with demos, and then close out with some reminders, kind of thing. So with today's focus being on JavaScript, I think in the past I've done like one JavaScript vulnerability, showed fixing it and how Snyk helps with that. And then I would jump into some Docker stuff too and whatnot. But I think I want to try and explore for the first time in this same repo that we've used, this demo project that we use that's intentionally vulnerable. Let's try exploring some of the other vulnerabilities that are part of it. And I've never done it before. So we're going to see firsthand experience of just like learning on the spot together. What do you say? Does that sound good? Something different there for us to do? I see more folks in chat chatting here. Minus one vortex. Can JavaScript attack surface increase from too hard to measure to infinite? Let's see. That's yeah. I like how you put that there. All right. So let's jump into the presentation. What do you say? How are things looking, by the way? Last time, in terms of quality of the stream, last time some folks said things were fuzzy. So I'm going to switch over to share my screen. Let me know how this kind of looks for you all. By the way, I'm like superimposed in here. Fantastic, right? I'm loving it. We can get rid of the name thing. Hold on, let's do that really quick. Looks great. Okay, Gerald, thank you for covering. All right, so I jumped ahead a little bit. As I mentioned, stranger danger, your Node.js attack surface just got bigger. I'm Brian Clark. You can find me on the internet at on some places my name was taken. I have a common name, okay? So but somehow Clarkio is taken in a lot of places too. So I prefix it with an underscore, like a private variable in coding. So you'll find me on Twitter and Instagram with the underscore. Anyway, enough about me. What is the future of software? Open source software security. Words. English is my first language and I still struggle with it. So props to people that can speak English as a second language too. So, what is the future of it? I don't know. I think open source is going to continue to grow. There's going to be more and more open source software in various focus areas, right? I mean, there's just typical web development, which is what we commonly use or predominant not commonly use for JavaScript, right? But I mean, there's embedded systems, there's machine learning, there's AI, mobile development, what have you. There's more and more open source software to fulfill the needs in these new spaces, these new technology areas that we build out. And so it's going to be ever expanding. And if you think about that, it's ever expanding, then that means the security issues that we run into are going to be ever expanding as well. So that's kind of why we're setting the stage with that question. Okay. Well, oftentimes, when especially early days in my development career, when I would be approached by my team lead, my manager, and they say, "Hey, listen, Brian, we need you to focus on making sure the code you're writing, the app is secure, right? We're keeping security in mind. We need you to focus on that." And I'd be like, "Okay, cool." And right away, right off the top of my head, like my thought would be, "Okay, I need to focus on my code. Like, am I making sure I don't have anything vulnerable in my code that would leave our end users, our business, vulnerable to security issues and being exploited and whatnot, right? So right away, like I'd be looking at maybe this is my code here. Maybe you see some security issues in this code, right? And you're analyzing that. And it's a good place to start, right? It's natural to think that way. However, as the imagery shows on the left-hand side there, that is just the tip of the iceberg, friends. There's way more beyond the surface that we need to think about from a security perspective. The first layer we're going to talk about is open source code. In a study done by Snyk back in 2019, which I think we probably need to update this and see what the numbers are to this day, but at least at the point of 2019 when the study was done, 80 to 90% of code bases is open source code. What do I mean by open source? So this is something that took a little bit of understanding here. Like when you have third-party dependencies in your application, right? So you have your code, and then you have typically open source code, which is stuff that is uh, publicly available to other developers to share and reuse, so that you don't have to recreate the wheel, right? You don't have to rewrite the same code. Somebody's already solved that problem, written that function, whatever it is that you're needing, like maybe doing my common example I go to is date time math. Kind of better quality in minus okay, that's good to hear, -1 vortex, and no lag. Okay, good. Thank you, Gerald and -1 vortex for giving me that feedback. And keep me posted if anything changes over time, because 'cause I'm trying to improve that from last time. So, that is a lot, 80 to 90%? That's wild, right? I mean, again, when I'm thinking back, I'm early in my career or even recently, right? I'm believing that most of the code that is running in production is my own code, but the reality is it's mostly my dependencies that I'm leveraging to fulfill the needs of my app that's supporting and running my code. So that's pretty wild, right? And then on top of that, right, when it comes to security vulnerabilities in that open source code, it's not always direct dependencies. It's not always things that I purposefully chose to include in my project. It's actually what those projects purposely chose to include to support them, especially when it comes to the JavaScript ecosystem where everything seems like it's a package, right? We've gone hog wild where, well, one, I think it's partly because there's not not necessarily always built in to a standard framework or standard library as part of Node and just web development. So we've taken this approach of building piecemeal modules that we can pull in as needed and keep it kind of small and isolated, which I think is there's a good there's pros and cons to that, right? But because of that kind of culture and approach to this, there's lots of modules out there, lots of packages, open source out there. And therefore many of the larger open source libraries you might depend upon several smaller or other large libraries out there. And 80% of the time in the study, it was found that 80% of the time, vulnerabilities that were alerted to or found are really through transitive dependencies or like child dependencies of your direct dependency that you didn't actively choose, but they chose the maintainers and creators of that library that you're depending upon, which is also very troubling to some degree. And this is all not to like scare you and be like fear mongering. It's just to raise awareness of like, whoa, I hadn't thought about that before, which is understandable, right? This is don't feel bad if you haven't thought about that before. So that in mind, given some examples here, like this one in particular, Dust.js LinkedIn had a code injection vulnerability. And then going further here to more visualize what I'm talking about, right? Maybe your code is only a few lines of code. In this case, I'm using a marked library to do markdown rendering in the browser, and we're going to see an actual example of this in the demo application. But the reality is, the rest of your app is consistent of these npm packages to support and run it. More that was found in that study was showing how many new packages are created year over year. You could see, it just seems to be growing and going up, especially when it comes to NPM, but even a little bit to other, this is not limited to just JavaScript. This is also a possibility and actively happening in other programming languages in their ecosystems. And to that effect, right, what we were saying before with that question of like, what is the future of open source security? As there's more packages available and growing, and the whole overall availability of how many libraries are out there grows, that's more lines of code, and therefore that's more possibilities for vulnerabilities in it, right? So with that, you can see that year over year, for the most part, all of them, regardless of what programming language and ecosystem is, have grown in terms of how many vulnerabilities were discovered and disclosed each year in each ecosystem. So, something to keep in mind. And this is what we talk about this is what we call it when we talk about this particular issue, which is open source supply chain security, or at least it's part of that open source supply chain security. An example of that was from 2018, where in this case, it wasn't like maybe your project, and this is the timeline of like events, no pun intended here. Timeline of events that happened and occurred with this vulnerability related to event stream. But if you were depending upon this library event stream, it had a child dependency called flat map stream, and it had the vulnerability in it. It's like, what do you do then? Right? You didn't choose that. We'll get talking about that. So when it comes to picking your open source libraries, right? I can't emphasize this enough. I wish this was available when I first started my career as a developer, or I learned of it sooner than I did even to this day. Snyk Advisor. It is so I create a video on this that's up on the Snyk YouTube, youtube.com/snyksec. Maybe you're watching from there right now. Thank you so much. Robert Tables, good to see you, buddy. Thank you for joining us. This video is about choosing open source libraries. And there's a lot that goes on in with that. In fact, in a past job, we spent several iterations. We were following agile methodologies. We spent several iterations, which consisted of months, I would probably say, of finding and deciding what open source libraries we want to officially support, ordain as libraries that we're going to use in our web projects that we're doing. And this was for a company where we were like helping decide this of like for all development teams too within our architecture. And we manually went through and found like, all right, again, going to the example, date time math. We went through and we had like a set of criteria of like, is it actively maintained? Is there a lot of support around it? Is there community, asking very valid and interesting questions that we might also have those same questions and then see the answers to very quickly so that we can resolve issues we run into when using these libraries? Is it secure? Right? Is it, so all these factors, we had this criteria that we were following and we manually checked these things and like had a spreadsheet. Now you don't really need that. You don't need to do that manually, is my point. You can go to Snyk Advisor, snyk.io/advisor, and you can search for those packages. Search for packages that and see them and evaluate them based on this criteria: popularity, maintenance, security, the community. Is it active? And it gives it overall package health score. Highly recommend checking out the video, not just because I made it, but because I think it's super helpful and really great to have in your developer tool belt, if you will. And thank you for sharing that link, Gerald. Appreciate that. Um, so in any case, it'll help you find quality open source libraries to use in your projects that solve the problems that you need to. In this case, the example we're showing here is Moment, which is doing more type of date parsing, validation, manipulation, math, date-time math. Although honestly, I probably should update this screenshot. Moment, I think, is deprecated at this point, and there's other solutions out there like Date FNS, which is is another great feature of Snyk Advisor where it shows you similar packages related to the one that you might be viewing right now. So in this case, related to Moment, a similar package is Date FNS, right? And I think that's kind of like the go-to package for that purpose nowadays. So in any case, check this out. Use this to help you find quality open source libraries, and it'll tell you about the vulnerabilities that are found in those libraries and what version to maybe start out with if you're just getting started pulling in a new library to your project. All right, enough said about that. So getting back to that study that we were talking about before, the vulnerabilities that were found during that period of time, in many cases were via either direct or indirect, and they broke it down. Excuse me, a little indigestion there. They broke it down by ecosystem, so PyPI, PHP packages, Maven, to show where majority of the vulnerabilities were found. In this case, Python, mostly in your direct dependencies where the vulnerabilities are found, whereas like on npm, it's more so indirect dependencies. And I think it goes back to what we were talking about before, where and I'm speculating here. I don't know the exact answer to this and whether the data backs it up necessarily. Maybe it does, maybe it doesn't. But in Python, they have more standard libraries. I think maybe they don't have as many libraries, open source libraries that are available as there are in like npm as an example, right? Um, so that might be what's contributing to this, but it's good to like understand this and see how things might differ between programming languages and their ecosystems. So how do you manage this? How do you deal with these vulnerabilities? You need to know about them, right? Well, that's where Snyk or a tool like Snyk, there's other tools that potentially are out there, but you're here watching it on Snyk. We're going to talk about Snyk. A tool like Snyk will monitor your projects for you, alert you to any vulnerabilities that are found, educate you on those vulnerabilities if you wish. Or you can just skip that part if you don't care to learn more. But it's always good to be learning, especially as developers, right? And then it'll provide potential fixes that you can pull in. When it comes to open source, it'll give you the possibility of opening up PRs that have the patch versions of the libraries that you need. In some cases, maybe when it's indirect like this, and maybe there isn't a vulnerability or there isn't a patch available in the library because open source, it's lots of times it's folks that are building these packages on their own time outside of their day jobs. And so they don't necessarily always get to fixing things in a timely manner because, it's not their full-time job. So in some cases, it might be a little while before a patch gets introduced and put into an official release. But in some cases, Snyk can actually give you like a patch of the patch, an interim patch, if you will, to hold you over until it's officially in a new version of that library that you're depending upon, or an indirect one. So this is why we're talking about, if you didn't realize it by now already, how this plays into the title, your Node.js attack surface just got bigger, right? And when we say attack surface, you think it's like surface area, right? The more surface area there is to drill a hole into, right? The more possibility that, I don't know, let's say it's a bucket, right? The more surface area is that to possibly have holes, the more likely the water's gonna fall through that bucket and leave, not fulfill its need. I don't know, I just threw this metaphor out off the top of my head right there. Not necessarily the best one, I didn't really think it through, but you kinda follow what I'm saying. I'm trying to give you a more, if you're not used to hearing that terminology, attack surface, thinking more in the real world physical, surface area. The more surface area there is, the more possibilities for damage to be done, right? Whereas if it's smaller, it's a smaller target, it's harder to hit. So that's what we're talking about here. When it's not just your own code that you're focused on when it comes to security, and it's actually beyond the scope of that, and it's because of these more lines of code that you're introducing from outside, that's what increases this attack surface, the ability to break into it. All right, so what does it look like when you add a project to Snyk for monitoring your open source dependencies there? The JS3 bucket. Yes, Gerald. Yes. Yeah, that's a good tie-in right there. So when you add a project into Snyk, this is kind of what it looks like. It's a bit cropped out version of it, but you'll see, right? In this case, we have this goof project, and in it, Snyk was able to pick up that we have a package JSON file, this manifest that's describing the dependencies that I have in it. Hey, no worries, coder grammar. Good to see you. Don't worry about missing the start. Um, and Gerald, no reason to be sorry about that. That's all good. -1 Vortex says, FE front end wise, React being the most popular JS and CSS library and other CSS tools using npm as a build system, uh, makes npm attack surface increase the attack surface of most tools using modern front end technologies. Yes, is a very good point. Thank you for sharing that -1 Vortex in the chat. Very cool. Keep the comments coming, folks. If you have questions, or if you're knowledgeable in this space too, you can feel free to correct me if I say something wrong too. I have no problem with that. But let's learn together. That's the idea with this whole thing. All right. So the project gets added. It detects the package JSON, which is defining the dependencies, open source dependencies we have, and then it analyzes based on what's defined there. It analyzes those libraries and um, figures out if there's any vulnerabilities based on the version of those libraries that we're using, and then gives us a summary basically, right? In this case, we have 33 high. It kind of categorizes them based on priority too. Not priority, severity. That's the word I was looking for. But the severity helps you prioritize which ones to try and address over time first. If you can't, because it's hard. Like, look at this. There's 33 high, 20, so we're looking at like what, 50, 60 total vulnerabilities in this particular project. You're not gonna be able to address all of them safely, let's say, right? Uh, Within a day even, right? You wanna take it piecemeal. So that's what I mean by, like, having the severity levels helps you prioritize, and we'll talk deeper into that. But in any case, we see 33 high, 25 medium, and 5 low. And so what you would like to aim for as we're getting there is maybe getting it down to 0, but that's not always necessarily the case. You decide what's a comfortable level for you, your company, your team, and your projects, right? Maybe some of the low severity ones really aren't that big of a deal for you all. After you read into them further, learned more about those severities, those vulnerabilities rather, and you decide we're not going to spend the time addressing those right now. Maybe push that off into the future, and you really only want to worry about high, medium level type of things. But yeah, How are you gonna be able to do that though, right? You need something to be actively monitoring, scan because as time goes on, new vulnerabilities are disclosed and you need to be alerted to those too. It's a constant battle basically of trying to keep up and maintain a good security posture when it comes to our projects and our open source dependencies. So you want it to be continuously scanned as we're describing here. Then, all right, that's just kinda right, and when it comes to JavaScript, right, that's an NPM that we're talking about that as an example here. That's just that one layer below the iceberg that you see there, right? We wanna take it a level further. There's more to this, right? And that's where containers come into play or functions as a service and static site, services as well to host things or generate and host, your resources. This is yet another piece of the puzzle when it comes to running and hosting and supporting the production version of our application, right? And some of the things to just rattle off a few that you see here. You have Docker, Versal, Google Cloud Platform, Netlify, AWS, Azure. There's all kinds of services out there, and there's security to be considering in those spaces when using those services as well. For today's purposes, we're going to focus on just the container side of things because this is yet another product that Snyk offers. So there's Snyk Open Source, which will monitor your open source dependencies and any vulnerabilities that are in there and giving you fixes to pull into your project to address those vulnerabilities. But then there's Snyk Containers, and Snyk will pick up on whether you're using Docker or containers in your project, and what are the dependencies that are defined within your Docker file. Just like you have a package JSON that defines your open source dependencies, you have a Docker file that defines your base image you're depending upon. Any executables that you're pulling in through that operating system's ecosystem, like apt-get, let's say, you're gonna pull in some binaries that way. Are there vulnerabilities in those pieces of software? Your npm installing your ecosystem dependencies as well. And then what about the runtime too, right? So just your base image might define the runtime in addition to other things within that base image that comes as part of that package. But the runtime itself could have vulnerabilities in it, right? Depending on what version of Node you're running in this example when we're talking about JavaScript. So that's why you want to be monitoring and being alerted to any vulnerabilities that are found in your dependencies of your Docker file. Coder Grammar has a question in the chat. Thank you and that's over on YouTube. Does Snyk provide fix recommendations? Yes, Snyk does. I will show more of that when we get to the demo portion of things. But thank you for that question, and let me know if you don't feel that you got an answer as we get more through that. But the short answer is yes. Snyk does provide fix recommendations directly in the UI. So what I'm demonstrating here right now, or not demonstrating, presenting to you here right now, is the web app, the UI when you go to app.snyk.io after you've signed up for Snyk and you've imported some projects to it. Okay. All right. So when going through what I was just saying, right? This is for folks that maybe aren't familiar with a Docker file. This is kind of how a typical Docker file might define the container that we need in order to support and run our application. So we built a Node application. We need a Node base image that's going to have the Node runtime available to us to run our code. So we have the base image, but are there any vulnerabilities found in that? And talking about that a little bit further, that same study that we were mentioning earlier in the presentation, it found, again, this is 2018, 2019. I believe or hope that we're going to be doing this study again further to see how things have changed since then. But at that point in time, at least, you can see the number of vulnerabilities that were found in official container images, which is very interesting to me because I've in my own personal projects, I'm using Snyk to monitor my projects, and some of them that I'm using Docker and containers for. I'm like, how do I keep up with this? Right. And basically, what I've learned from my colleagues that are much more knowledgeable in this space is when it comes to the containers, we kind of just want to get it down to a minimal as much as possible. It's a little bit more difficult to get down to zero across the board, like we were looking at when it comes to like the package JSON. I've done that successfully before in some of my projects, but I've yet to do that one in any of them that are using Docker containers. But that's okay. It's kind of okay, is essentially what I'm getting at. So in any case, you can see basically the more minimal container image you can use, the better is what you're seeing. You can deduce from from here, and I'm kinda in the way, but you can see, like, if you just go down to the straight up Ubuntu image, it's at least in 2019, it got down to 0 vulnerabilities that were known in it. Altian in the Twitch chat says, "Basically, most of people, me as an example, are glad to even get Docker containers to run properly." Yeah, I feel you on that. I feel you. That's a good point. All right, so that's just talking about the base image, right? But then, as I was mentioning before, what other software might you be installing within that image that you're depending upon that you need to run your application? In this case, we're relying on this image magic tool, this software that's getting installed as a binary or executable within that container. Are there any vulnerabilities found in that? Then your open source dependencies again, are there vulnerabilities that are found through that? And then, as I mentioned earlier, what about the runtime itself? Does it have vulnerabilities in that version that's getting pulled in based on that image? Right now, we're just saying from node. And I believe in my Docker friends and container friends that are more knowledgeable in the space, like if I say that, is that going to get latest or is it going to get the latest stable version? I forget. Whatever it may be, right? It's going to be changing over time too if you don't define specifically what version you want to use. And so you need to be actively monitoring that and being alerted to any vulnerabilities found there. I'm going to pause and see if anybody wants, if there's any correction to what I just said, though. Doesn't look like it. Okay. All right. Minus one vortex is going with slim and installing poor binaries is another way to break your software. Not locking versions you don't have predictability. Yeah. If you version them, you have to maintain though. Yeah. Very good points. Very good points. Yeah. Thank you, minus one vortex, for that comment. All good information. All right. So we're gonna start hacking Node apps. Okay. First, we're gonna go and see a vulnerability and hack it. That's through a open source library that we're depending upon in a project. Then, and I think so this is what I typically would do, but we might change it up today. Also, we're at about half hour, the half hour mark. And I need to end at the top of the hour because more meetings after this. So I have a little bit of leeway with that. So we'll see how things go. But I think what I might change is we might jump into on the fly some of the other vulnerabilities that are described and documented that are in this intentionally vulnerable application beyond just this one open source library. But typically, what I would do from here is I'd go into the container side of things and demonstrate the vulnerability through some common software that we're relying upon and then the runtime. But I think we might skip that. So let's go into demo mode really quick. Boom, 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 boom. All right, let me share my screen again. All right, so let's put our hacker hats on, right? And as we got that perspective in mind, we're going to be thinking about exploiting things and understanding this application. So let's say we as developers had a requirement to build yet another to-do app, of course, right? That is the go-to when it comes to learning, especially, and having an example application to build as you're learning something, right? But we need to do this to-do app. It needs to be stored in a database. What we need to do. So I got to brush my teeth is the example I usually go with. I got to walk the dog. But we want to allow the users of this application, excuse me, to have a richer experience, be able to stylize the to-do items, if you will. So, maybe we wanna let them, bold things, so I think in Markdown, and let them we have our end users are developers too. They understand Markdown, they write things in Markdown, they want their to-do list in Markdown. So, to bold something, like, really do this, right? Brush your teeth, Brian. Your breath stank, boy. So now it's in bold, right? Or maybe I need links, right? In this to do, I need to make sure I go to check out Snyk, right? So I'm going to remind myself here and go to HTTPS. Make sure you use the S protocol, the secure protocol, snyk.io, right? And I enter that, and that allows me to click this, and then I go to those links. Hey, there we go. Nice, right? Cool. I can delete stuff if I want, right? Like I don't need to brush my teeth twice. Well, actually, I should probably have it twice, but I digress. And there you go. So that's what the app's doing, right? But as an attacker, I'm looking at this and I'm like, okay, I see there's some flexibility in what I can input here. Are they being the developers of this application, taking into consideration what somebody might try to do and enter as data that's malicious here. And how could it be malicious? If you're new to this, I'll describe these things as we go through. But if you think about it, this is all running in a browser. It's running in within the context of a browser, which means it's using HTML to render things to the page, maybe some CSS to style it and do some other fancy stuff to make it look nice, albeit is very, battleship gray going on here. Kind of, it's not very fancy, right? But you might use some CSS to do that. And then some JavaScript even to handle certain things, maybe make some HTTP calls, AJAX calls behind the scenes to go retrieve data or send the data to store in the database. So knowing that that's the context this data is being used within, we can start as an attacker, start leveraging that to our advantage, if you will. Maybe we can try things, right? So we know browsers run JavaScript code through an HTML tag called script. So what if we try to enter that as a to-do item, right? So script, closing tag, and then I wanted to run something. And so typically what you might do as an attacker just to see if something will actually run is you want to trigger the alert box to pop up that sometimes shows up. Maybe you've seen that before if you're new to this. And get it to say something, show something like hello, right? And then we want to close out the script, right? So closing script, and this is just HTML HTML putting JavaScript code directly through a script tag in an HTML page instead of having it referenced like a separate JavaScript file, right? So if I hit enter and I send that in, oh, okay. So it didn't do anything. It didn't execute that script. I didn't see the alert box pop up in my browser. So as an attacker, I might mean, okay, well, that didn't work, but I'm not deterred. Not yet, at least. But what I can see here, if I analyze that, I can see it basically took what I put it in as and rendered it that way. So what this is called is HTML or is input escaping, right? So when it comes to handling user input, you have to try and account for all types of cases, not just the happy path, not just what you expect them to do. As a developer, a lot of times we get narrow-minded, we get tunnel vision on, I just need to implement, at the end of the day, this is what I'm getting paid for, right? I got a task come into my queue that said, Brian, you need to allow the end users to use markdown syntax in their to-do list, right? And I go, okay, pull in this library that lets me do that. Boom, up and ready to go. Push to production, done, right? And I'm expecting that the users are only ever going to use markdown syntax in there. In this case, this was a script. Now, fortunately, the library that I'm using has got some security built into it that's helping detect this particular approach to attacking things. Um, but maybe I didn't know that, right? I didn't even think to try inputting this as an example. But an attacker having that mindset or trying to, after you develop something, switching gears to that attacker mindset, how can I break this thing? Kinda why we do testing and all that kind of stuff. It helps us figure out what are the unhappy paths that, we need to account for. So this is one of those examples, right? We need to handle user input and ensure it is up to our specifications of what we're expecting. And if it's not, we need to handle that properly. So in this case, what they're doing, or at least I think the library is doing here for the developers of this project, is it's doing input escaping. And what that means is it's identifying key characters or keywords that are known to be, they're a deny list, basically. You have a deny list of things that people will try to do something malicious and break stuff. In this case, having script tags in there. So it'll know then, okay, when we receive that, we can either completely remove it out, which would be input sanitization, or we can encode it for the context in which the data is going to be used. So this case, the context is HTML. So we can HTML encode these special characters like the angle brackets and the parentheses and all that stuff. Maybe I don't know what extent that there might be doing that, but you get the idea, right? And then leave it intact, and that way it gets rendered to the screen. That's what's going on here. I see minus comment from -1 vortex in the chat. Are we going for parentheses plus square brackets exclamation? No, 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 we're not doing that. Yeah, I know what you're referring to. But no, we're not going to that level. But that's a possibility. And for folks that maybe are wondering what I'm talking about, there's ways that's valid JavaScript right there that -1 vortex is sharing that could potentially be inputted into here. In fact, if I do that, would that do? Let's see. Let's test it out actually, right? It just encodes it and renders it to the screen. So, but you can Yeah, look that up a little bit, folks. What is it? Is JIT? And I don't want to say the word, but there's a certain JavaScript approach to writing JavaScript where it's just like a limited set of characters instead of the typical standard keywords that would be used in JavaScript that consist of just like these type of characters. Check it out sometime if you haven't before. And thank you, minus one vortex, for bringing that up. All right. So as an attacker, I tried that, didn't quite work. But there's another way we could do this, right? We know that it allows for links. So through Markdown, so we just enter in the parentheses here a link that we want. And one of the options that we could have a link go to would be the JavaScript protocol ish. I don't know if that's the correct way to describe it, and put in the alert that way. And let's see if that is a possibility to execute and trigger an alert box. Oh, but we are getting different results now, right? It's not, it's no longer encoding it. It's instead, looks like it might be using sanitization. So it's removing the malicious input, which was like all of it, essentially, except for the last parenthesis there, which is interesting, right? But we know as an attacker now, we're like, okay, we're getting different behavior as a result of trying to exploit this application through, or this website through a markdown link. So we can keep iterating on this. Maybe we try, trying to figure out how this application is protecting itself. How is it preventing the malicious input from being able to actually execute something? So maybe it's looking for and keying off of this colon, right? And maybe, so imagine the logic is something like if data equals, and then it's a string that says JavaScript colon, right? If that's the case, what if we maybe use the encoded version uh, of the colon key, right? Which would be ampersand 58, I believe. Right? Oh, ampersand pound 58 semicolon, right? Which is that way of writing out the colon, but without the actual character itself, right? So if I enter that, we still get the same result, right? And we just keep iterating on this and iterating on this. But the one that does indeed work is going to be this one. And I'm going to share it in the chat, share it, copy it actually, so I don't have to manually type it out. So this one is the one that works, right? And let's step through what's happening. So we got the link text, still using that JavaScript keyword. We are encoding using the encoded version of the colon, but we're adding in this in particular, no pun intended, but this could be like window, just another valid JavaScript keyword here that does nothing. It doesn't alter the behavior of our code that we're trying to do. We're just saying this, and it just won't do anything. Like if you just write that in the browser console, even try doing that real quick. Make this a little bit bigger. And if I just do this in here, right? Like it just works. Like it's just going to return the context of what this is within that scope of this code that's running here. Okay. So it's not going to do anything. It's just going to return something, but that's it. And then we run the rest of our code, which is the alert, and we want to see if we can trigger the alert to actually happen. That's what that way we know this is successful. And we use the encoded version of the closing parentheses on that. So if I enter that, let's see what happens. Ooh, we got somewhere, folks. We done did it. Gotta love JS fuzzing. Always an adventure. Exactly, minus one vortex. So I can click this now, and bam, there we go. Marked exploit successful. I was able to trigger the alert box in the browser, and that shows to me that I'm able to exploit this application through what's called a cross-site scripting vulnerability. Now, you might be thinking, Brian, you you just you just hacked yourself? Like, what's the big deal? This is only on your machine, your browser instance. Why is this a big deal? Well, two things. One, as an attacker, I can now use this like this is stored in a database, right? So this is stored cross-site scripting. And I can maybe, let's say this to-do list is shareable with other people. That's a feature part of your application. I can now target somebody else, get them to go to my to-do list and potentially click on this link now to see, oh, make it clickbaity, right? Oh, click on this to find, cute puppies videos or something. Who's going to deny that? Or cute kitty cats? I don't know, whatever you're into, right? We're into dogs here, though. We're into dogs and cats, but I mean, come on, the Snyk logo is a dog, right? So you trick them into clicking on this, and then you're like, oh, well, it's just going to show an alert box on their window. Yeah, in this case, but you're seeing that I was able to. If can I edit this? If I click on this, or I'll paste it again. Like this is all I wrote right now, but what if I got it more JavaScript code in there? This is just showing that I can execute JavaScript code, but now I can write any JavaScript code I want. So what that might mean is I can write an XHR request to send to my API that I have running, and that will ingest any data that gets sent to it. And then again, you might be thinking, whoop-de-doo, Brian, who cares? I care, okay? I care, and you should care too, because what an attacker can do from there is they can start pulling out sensitive data from the victim's browser. They can pull out cookies, the data from cookies. Maybe they have tokens stored in session storage. Maybe they have other sensitive data like address information, privacy concerns, privacy related data in local storage or something. And they can start exfiltrating that data out of the person that they're attacking or they're taking advantage of here and use that to their advantage. They can start then maybe they get their auth token, right? And then they can log in and impersonate them as part of this application. Again, this is just an example app. It could be like a bank or whatever, like something more serious in this case instead of a to-do app. Like who cares about having access to a to-do app? But this is just a demo. This is showing you the possibilities. This is stranger danger. So that said, that's why this is a problem. That's why this is a little bit more serious than what you're seeing where it's just an alert box that's going on. Okay? So there you go. That is an example of hacking through what's called a cross-site scripting vulnerability in the app. So let's understand this a bit more, right? So we see we've learned about this, and this is something that is important to see as a developer because you need to know what you're defending against. And a lot of times, especially in my experience, the security team at a company might be reluctant to share this type of information to educate developers within the company on how to hack, right? Because their concern is, oh, well, then these developers are going to hack us. But the reality is, I mean, sure, there could be a potential for that, but what's the likelihood of that happening? It's more likely that these developers want to stay employed and and be paid, and they want their company to be successful. So it's better to educate them to keep the company secure, to keep your users and customers secure through the software that you're building. Uh, in the long term. So you need to educate the developers on the security vulnerabilities to be aware of how they're exploited. And that's why it's important. That's why we do this type of stuff here. And that's why I believe in sharing this information so that you are better equipped as a developer to understand why you need to do input handling, why you need to do input sanitization and escaping and whatnot. In particular, to deal with protecting yourself against an attack like this, a cross-site scripting or vulnerability that allows an attack like this, which is the cross-site scripting vulnerability. All right, enough jibber jabber. Let's get into the code, right? This is the one we're looking at here. So let's get you acquainted with the app a little bit more and how it's able to produce the features that we saw there. So in particular, we're going to go to not views, but rather, where was I? Service? No, routes, index. Where is it? You think I would know what I'm doing here? App.js. Yeah. All right. So what's enabling us to have markdown syntax is an open source library. Duh. I don't want to write that myself. So we're using this library that's called marked. Okay. And I pulled in, again, this is intentionally like an older example. It's intentionally vulnerable. So we're using var, we're using require. Don't get too hung up on that right now. This could still be the same situation, even in more modern approaches and syntax to JavaScript and Node.js. So I pull it in, and then let's search for where I'm setting it up a bit more, right? So marked. So here I am. So something to take note of when it comes to open source libraries. Ideally, you would expect them or hope for them to have security features on by default. That, unfortunately, is not really the case in a lot of situations. Sometimes yes, but sometimes no, because there's all kinds of things that could play and factor into that. In this case, Marked has an option to turn on the security features, which we are using, and we saw that even with using that, we are still vulnerable. We are sanitizing the input, and then so we set those options, and then we just set it up to be used in our application, and we're all good to go. That's it. Done. Uh, so that said, you think you're good, right? Like, but we're vulnerable here. So how do we know about this being an issue? Well, one, I can use the Snyk extension, which I think is did encounter a problem. Need to restart. And this allows me to analyze my open source dependencies directly in my code if I wanted to, along with some of the other services or products that are provided by Snyk, like code security, like code analyzing, right? But in particular, I can look at all of my vulnerabilities that are found in my open source dependencies directly here. And some of them are marked. So in particular, we want to look at, I can find that. I don't know which one it is here, so we're going to figure out. Is it this one? In any case, I don't know which one it is. I forget since they're not basically the one that we just took advantage of that I demonstrated. But it's one of these cross-site scripting ones that are defined here through the marked library. So what's great about this is you don't have to leave your editor. You don't have to leave VS Code. There's plugins for other editors out there too if you want to explore that too. But in any case, you can stay here within the context of where you're writing your code and learn more about the security vulnerabilities in your open source and start addressing them over time. You can learn more about them. In particular, I like reading the Snyk write-ups on these because just like with Advisor, it just gives me all the information in one place and makes it very easily consumable. So I can learn more about I think this is the right one. I can learn more about how the vulnerability is possible in that library, like the overview, the details of it, the types of attacks that are available or possible as a result of it, and all kinds of stuff. I could see who was the person that found it and disclosed it, when it was, and all that fun stuff. And getting back to what I was talking about before, let's look at the PR actually of when this fix for this vulnerability was opened. So this individual, Matt, opened up a PR on May 19th, 2015. It didn't actually get merged until 2016, nearly a year later, or a little bit over a year later, right? So it goes to show you again that open source, somebody, it might be one individual that's maintaining this project, and it's going to take some time to necessarily get a patch into the official version that's published on the package there. And this is the nature of open source, right? So you can find out all this information directly from the write up, thanks to the Snyk vulnerability database that provides that there. Minus one Vortex says you can be alerted about container issues around your images without applying Snyk into your supply chain. New Docker desktop has a new extensions plugin, and Snyk has you covered there too. Yeah, yeah, yeah. Good points. Good points. Thank you for bringing that up. Minus one Vortex. Uh, did I want to share any more about this? No, I think that's about it. So in any case, you can learn more about it, but then in your application, so if I go over to I've already imported this project into my Snyk account. I'm going to click on it. I think here, is this it? Yeah. Yeah. I can search for marked in this one. Give me the same stuff that we were seeing before. So I'm filtering all the vulnerabilities that were reported by Snyk to me about this project and the dependencies that I have on it. And I can filter down to just the marked ones, right? The marked library. And let's say I think this is the one again. I can choose to, and I'm in the way a little bit, but let's move it up. I can have Snyk open up a fix for me. So I click on that and it will let me choose which ones I want to open up a fixed PR. I can include multiple, all of them, or just one. I like to go piecemeal, especially um, if there's like a major version change or, like if the API of the library is changing, we need to test that first. So I try to like go piece by piece in my own personal projects so that I don't necessarily I can make sure I'm not breaking anything when it comes to this. And so you do that, scroll down. There's so many in this one. And I can say open a fix PR. Right. And then what that's going to do is this project's up in GitHub. Of course, something went wrong with that. Demo gods are not on my side, but it will open up a PR in the source control system that you pulled in this project for. So in this case, I use GitHub, but I can go in and I can it doesn't have to be GitHub. You can do Bitbucket. You can manually edit through the CLI on your local machine. You can monitor public GitHub repos that are out there if you'd like instead. There's lots of options to add projects to be monitored by Snyk through the UI itself, in addition to some of the local machine stuff like through the CLI. So in any case, those are your options there. And then this is like that from the slides that we were talking about before. So being that we're close to at time, I think I'm going to start wrapping it up there. So let's really quick fix this, right? So how do we fix this? We upgrade to that version, right? So I can have the PR do that and merge it and then pull down the branch that PR is on to my local machine run my tests, make sure everything's working fine and still behaving the way I expect it, and then merge that based on how that goes, right, after I review it. Or I can just come in and manually, like, if I don't know if I have time to do this right now, but if I come into my terminal and I stop the app and I say npm install marked at that correct version, which is going to be 0.3.6, let that run, take a sip of coffee, go to the water cooler and talk to our colleagues, come back, and the install should be done in 3, 2, 1. Look at that. Perfect timing. So now, if I tell it to scan my open source projects again, we should see it cut down. Again, this is through the Snyk VS Code extension. Uh, we see at least one less cross-site script. There was 3 before. I'm in the way. There were 3 marked cross-site scripting vulnerabilities before. Now we're down to 2, right? Just to show you that that does indeed fix it. And this is all testing it locally, um, and making sure that, things are good to go. So that's how you go about it. We saw how to attack a vulnerability that's found in an application through an open source software that we're relying upon in our app. And we saw how we can learn more about the vulnerabilities that and be alerted to them through Snyk. And last but not least, how we can fix them, either using Snyk's ability to open up PRs for us or just manually upgrading and testing on our local machine to see how that goes. Any questions, comments, thoughts? What do you think? The idea of this though, right? Like, regardless of what you use, it's important to be monitoring your applications, to be monitoring the open source libraries that you're depending upon, because as time goes on, as code changes in those libraries, there's potential for more vulnerabilities to be found. Or even if the code doesn't change, maybe people just find unique, clever ways to exploit those libraries still. And it just hasn't been discovered yet. It's just sitting out there waiting to be discovered. And then it finally is discovered and somebody discloses it. You need to be ready for that kind of stuff. You need to know and be aware of it, right? So thank you, minus one vortex, for the nice comment there as well. Cool. All right, let's jump back over to the presentation momentarily here. Oh, where did I put it? There it is. And we'll wrap things up. Okay. So yeah, we just focused on the open source library for today. I got deep into discussion, just going off on trying to share more knowledge in other spaces. But we have more Snyk lives, more stranger danger in particular Snyk lives that are coming up. One focused on Java should be coming up in a couple weeks. We have more JavaScript streams coming up this month too, but I'll get to that in a second. So let's close this out. So what can we do about it? Make sure you are actively monitoring your applications for open source dependencies. Make sure you connect your container images too, to be scanned and monitored as well. And then when it comes to containers, try to keep them as minimal as possible. We didn't get into the details of that, but yeah. Hey, what's up, Noob Coder? Good evening to you as well. Thank you for joining us. So that said, you can check out more over on snyk.io, the blog. We have lots of resources there to help you in educating yourself. There's Snyk Learn too. In fact, you know what? Let's minimize that. Let me just show you. And let me drop the links in the chat too. So we have um, the first one I want to share with you is this one. So if you want to learn more about what Snyk can help with JavaScript related projects, you go to snyk.co/js, which I'll do directly in my browser here, snyk.co/js. And that will bring you to Snyk Loves JavaScript page, where you can learn about all the stuff that we're doing this month related to JavaScript. We've got lots of live streams coming up here for that in particular. Let me drop the link in the chat as well for folks. HTTPS snyk.co/js. Share the link in the bio too. Yeah, we should do that. That's a good idea. Thank you, Noob Coder. So what are we doing? So today is May 11th. This is this session right now. But then there's also tomorrow. Our good friend Micah and Kyle, our fellow advocates here at Snyk, are going to be doing a Capture the Flag 101. So if you've never done a Capture the Flag before and you want to learn how to do that, it's a great session. I saw a private one that they did that was super helpful, super educational, and I learned quite a bit because I've not done capture the flags before. So join us for that tomorrow. I believe that's going to be at noon Eastern, and 5 p.m. GMT. Then we have a live hacking session coming up on May 17th. I'm going to be part of this one. Um, and that one's by Micah, the live hacking session. Then May 19th, we're going to be doing JavaScript community highlights. Essentially, we're going to find clips from on Twitch. It's going to be streamed to both Twitch and YouTube, but the clips are going to be from Twitch of fellow JavaScript developer streamers that have just awesome moments in their stream that are like cool stuff working, maybe some bloopers, funny moments, that kind of thing, getting mad at their code. We're going to try and find some fun clips and help promote fellow JavaScript developer streamers on the platform. Then we're going to have another instance of our live trivia on May 24th. That's going to be with Laron is going to be joining us for that one. And last but not least, towards the end of the month, we're going to have a fireside chat with fellow Snyk ambassadors on May 26th. So lots in store for you. You can learn lots about how to use Snyk and what Snyk offers when it comes to JavaScript projects as you scroll down. The one that I was going to point out here is Snyk Learn. Let's open that in a new tab as well. This is super helpful, right? Because they're basically like hands-on demos that you can do yourself to learn about different security issues to be checking out. Open redirect, code injection, server-side request forgery, directory traversal, cross-site scripting, which we saw today. But there's all kinds of security vulnerabilities that are possible that you want to learn about. Maybe you don't know about these things like prototype pollution, right? You can start a lesson that will teach you about those so you can understand them better. In addition to like the write-ups that I was showing you before, like this one that teaches you about that. It gives you like a more concrete example in the wild that you can see, you know? So highly recommend checking out learn.snyk.io as well. This one is focused on um, JavaScript, but you can switch to other ecosystems too. You can see we have it for Java, Python, C Sharp, Kubernetes, Go, PHP, and so forth. Right? We're all about trying to help educate and level up people, developers in particular, around security. Okay, I think that about does it. Oh, if you haven't done so already, we have a Discord. So if you want to stay connected, devseccon community, is it right? What is it? Gerald, are you still there in chat? Or there it is. Join the community. Get involved. Find us on Discord. So Snyk and DevSecCon is powered by Snyk, or DevSecOps community rather. We have a Discord that you can join up at. You can go there. I think what's the link here? DevSecCon.io Discord community. Yeah. So that's a great way to keep in touch with other folks that are learning about security, sharing resources. The Snyk ambassadors are in there. Folks from Snyk are in there. So if you want to get in touch with myself or anybody else and discuss various topics around developer security, feel free to hit us up. There's the link to join that. All right. That about does it, folks. We are out for this Stranger Danger. Thank you for tuning in wherever you are in the world. I hope you have a good rest of your day. And we'll see you next time. Be sure to tune in. Drop a follow on the stream. Subscribe on the YouTube if you're watching from there so that you can get more awesome content from these channels. We'll see you next time and have a good one. Peace out. Thank you, Minus Vortex. Cheers to you as well. Adios, amigos. Bye bye.